Hello friends. In this lecture we are going to discuss about neighboring group participation, and as the name suggests only there is an important role of neighboring group in this mechanism. So let's see about it. In case of neighboring group participation, SN2 mechanism plays important role. Two different SN2 reactions take place. Firstly, in case of a normal SN2 reaction, we have one nucleophile, which is external nucleophile, which attack on this carbon species, and there is one living group. Suppose in this case we have this Br as a living group. But as this external nucleophile in first step attack on the carbon, it will give you a transition state in which there is OH as well as Br minus present. Here is attacking nucleophile, that is OH minus, and leaving group, that is Br minus, present in the same transition state. And nextly it will give you a substituted product, that is OH minus is now attached to carbon and Br minus is eliminated out. So in normal SN2 reactions, the external nucleophile like OH minus is attacking on the carbon species. If there is any nucleophile is present only in that molecule, then that nucleophile may also gives attack on the carbon. That is only happening in NGP reaction, that is neighboring group participation reaction. Let's see about it. In NGP, that is stands for neighboring group participation, the important points are: firstly, NGP contain two successive nucleophilic substitution reactions, and these two substitution reactions, first one is intramolecular SN2, means that SN2 reaction will only happens in one molecule, and which is followed by intermolecular SN2 reaction. From NGP reaction, the final product which will you get with completely retention of configuration. And finally, as the neighboring group is participated as a nucleophile in this reaction, so it is called as neighboring group participation reaction, that is NGP. Let's see about it. Suppose we have a molecule containing leaving group and one atom or a group which contains lone pair of electron. Now, in molecule, we have that atom which contain lone pair of electron may attack on this carbon like this, and leaving group will be eliminated out as L minus. So in this reaction, simply SN2 reaction takes place, but this is intramolecular SN2 reaction, right? In case of SN2 reaction, the one group which is act as a nucleophile attack on the carbon species and leaving group eliminated out, and simply it is attack from backward position and leaving group is eliminated out as an L minus, right? So this is a simple SN2 reaction, but this one is intramolecular. The reaction which takes place in within the molecule or within a same molecule is called as an intramolecular reaction. So this type of intramolecular SN2 reaction. So by first intramolecular SN2 reaction, that reaction gives you product like this. This will give you a cyclic intermediate. Now, after a first intramolecular SN2 reaction, the reaction mechanism is followed by second SN2 reaction, which is intermolecular SN2 reaction, means a outer nucleophile will attack on this carbon, so it will gives you intermolecular SN2 reaction. Now there are two possibilities: this nucleophile may attack on this carbon or it may attack on this carbon. As it is symmetrical structure, the nucleophile let's attack on this carbon. When an electron from this ZC bond will shift on this Z, and as Z will restore its electron pair. Then after the intermolecular SN2 reaction, you will get the last species, that is last product, as this. Now here you can see the Z is present on this carbon, which is in the reactant molecule also it is present on this carbon. So the position of Z is not changing. Now at initial stage, leaving group is present on the second carbon. Now the nucleophile has replaced that position and it is present on this carbon. Now in this whole reaction, the first reaction is intramolecular SN2 reaction and second one is intermolecular SN2 reaction. So you can see first intramolecular SN2 reaction will give you first inversion, because SN2 reaction will gives you inversion of configuration. So as per the first intramolecular SN2 reaction will gives you first inversion, and in next step there is a intermolecular SN2 reaction, that is a second SN2 reaction. So again there is inversion of configuration, that is second inversion. So inversion, it will give you retention of configuration, that is important point. So in case of a NGP, inversion, You can see there is a first inversion because of this first intramolecular SN2 reaction, and second inversion here because of this intermolecular SN2 reaction. So inversion, the net results in retention of configuration. Means suppose this molecule, reactant molecule, contain R configuration, then after first SN2 reaction it will gives you S configuration. Then after a second inversion, this S configuration will inverse to R configuration again. So first it will be a R, and lastly it will also get R. So it is inversion means net result in retention of configuration. This is the important point about NGP reactions. One more important point about neighboring group participation reactions is that the rate of these reactions depend upon only substrate, as the first intramolecular SN2 reaction is a slow reaction and second intermolecular SN2 reaction is a fast reaction. So the attacking nucleophile Z and leaving group L both are present within a same molecule, and there is no any participation of external nucleophile here in this slow step or rate determining step. Because of that, the rate of this NGP reactions are depend upon only one substrate. So there is a first order rate reactions. In normal SN2 reactions, the external nucleophile plays an important role, but in case of NGPs, neighboring group participant plays an important role. So the main point about NGP is that atom or a group within the molecule act as a nucleophile and gives SN2 reaction. So we can call it as neighboring group participation. Here you can see this atom means any atom which contain lone pair of electron, or it may be a pi bonding system, or it may be a sigma bonding system. It plays an important neighboring group which act as a nucleophile and leaves out this leaving group. So atom or a group within the molecule act as a nucleophile and gives SN2 reaction. That's why we call it neighboring group participation. Or you also called anchimeric assistance. Here anchimeric means there is a neighboring group. So neighboring group assistance or anchimeric assistance. Nextly, the common feature of all NGP mechanism is that the formation of cyclic intermediate. Here you can see there is a cyclic intermediate formation takes place in all NGP. It will give you cyclic intermediate formation, and because of that only after a second inversion you are getting restoration of same configuration. The next important point is these reactions are thousands times faster than normal intermolecular substitution reactions. As you can see, in case of a SN2 reactions, the attacking nucleophile is important, and as this attacking nucleophile is present within the molecule, that's why it is easily can attack on carbon and leaving group easily eliminated out. Because of that, these reactions are thousands times faster than normal intermolecular substitution reactions. And one more important point, that is NGP reaction follows first order rate law. Here you can see as attacking nucleophile and leaving group both species are present on the same molecule, that is within the same substrate. Therefore, the rate is directly proportional to concentration of substrate. So this is some important point about NGP. Let's see some examples about NGP now. In case of NGP, there are some groups or atoms which show anchimeric assistance. Let's see one by one. There are NGP by unshared pair of electrons. Here you can see the atom which contain unshared pair of electrons. It may be oxygen, so oxygen as a neighboring group. Then sulfur may act as a neighboring group, as well as halogens containing lone pair, they can act as a neighboring group, and nitrogen is also there, so nitrogen as a neighboring group. Again, there are some system which contains pi bond, it may also act as a neighboring group, and some sigma bond systems also. So let's see about it one by one. So let's start with NGP by unshared pair of electrons. So out of that, first one is oxygen acting as a neighboring group. Here we have one species, that is bromopropanoic acid. One classical example of neighboring group participation is the alkaline hydrolysis of 2-bromopropanoic acid. We have the species, that is R2-bromopropanoic acid. Here its configuration you can see. Its priority order will be Br at first, Me at second, and hydrogen at third. So first, second, and third. It is going on clockwise direction, so it will be R. So we have this R2-bromopropanoic acid. In alkaline solution, it will act as this OH minus. Simply this OH minus will abstract this hydrogen. It will give you O minus, that is anion. Here this carboxylate anion we'll play neighboring group participant, and this electrons will attack on this carbon and Br minus is eliminated out, and finally you will get this type of intermediate, that is the cyclic intermediate. So this one was intramolecular SN2 reaction, and it will give you first inversion, because as it is a SN2 reaction, it will give inversion of configuration, and it is a slow step reaction. So in all process of NGP, there is two SN2 reactions. Already we have done first reaction. The second one will be intermolecular SN2 reaction. Now we have this OH minus will attack on this carbon species as per this, and electron will be shifted on this oxygen. So there is a restoration of electron on oxygen takes place, and you will get final product with restoration of electrons on this oxygen. So firstly we have R configuration. After a first inversion, first intramolecular SN2 reaction, you will get a S configuration, and after the second inversion of intermolecular SN2 reaction, you again restoration of R configuration. You can see OH have first priority, Me has second priority, and hydrogen means low priority group at below side. So 1, 2 and 3, it again contain clockwise direction, so it is again R. So R converted to S and S again converted to R. So there is restoration of configuration. So finally, as in case of NGP, inversion, finally you get retention of configuration. Now the important point about this reaction, that we are doing this reaction in dilute alkali, because of that we are getting this NGP type of reaction. However, in presence of a strong alkali, that is concentrated sodium hydroxide, it will give you inversion of configuration, that is the reaction will goes by normal SN2 reaction and it will give you only inversion of configuration. The another example of oxygen acting as a neighboring group is the acetolysis of 4-methoxybutyl borosylate. Here you can see we have a alkoxy group, that is oxygen is attached to one methyl group, that is OR bonding, that is alkoxy group. So oxygen act as a neighboring group in presence of hydroxyl group as well as in presence of methoxy, means alkoxy groups. So now in this condition, oxygen containing lone pair will attack on this carbon by first SN2 mechanism. So this is intramolecular SN2 reaction, and it will give you intramolecular attack when within the same molecule. So this oxygen containing lone pair will attack on this carbon, and this electrons from this carbon oxygen bond will shift on this oxygen, and it will be eliminated as a minus OBS. Here OBS means para bromobenzene sulfonyl species. It is a good living group. So it will give you after first SN2 reaction, that is inversion of configuration, this type of product, that is cyclization takes place, right? The second step is cyclization. So the second step is acetolysis process, and this is the second SN2 reaction, that is intermolecular SN2 reaction. Why? Because now the nucleophilic attack is taking place by external nucleophile. Now this oxygen containing lone pair will attack on this carbon, and electron from this carbon oxygen bond will shift on this oxygen. So oxygen will restore its electron pair and you will get a final product. This is a second SN2 attack, that is a fast process, and it is not a rate determining step, because the first one, which is a slow step, is already a rate determining step. It will give a final product after opening of the ring. Now the important point about this reaction is that the acetolysis of 4-methoxyborosylate is 650 times faster than normal N-butyl borosylate. So the methoxy group is playing as an important role as a neighboring group participant, which increases the rate of reaction of this acetolysis process. Now let's see about the second example of neighboring group participant as a sulfur atom. So sulfur may also act as a neighboring group participant as it contains lone pair of electron. Here we have example of mustard gas. The base catalyzed hydrolysis of mustard gas is an example of neighboring group participation by sulfur. This electron pair present on this sulfur will attack on this carbon atom and Cl minus eliminated out. So this is the first SN2 reaction, that is a slow step, that is the intramolecular SN2 reaction, that is sulfur atom is attacking on carbon which is present in a same molecule, that is the intramolecular SN2 reaction, which gives you simple inversion of configuration. So formation of sulfonium ion takes place, which gives you 3-membered ring formation. Now the second step will be a second SN2 attack by this bottom molecule oxygen containing lone pair will attack on this carbon and electrons will shift on the sulfur. So there is a restoration of lone pair will takes place on sulfur, and proton will be eliminated out from the water molecule, and this is the second SN2 attack, which gives you again inversion of configuration. So final product formation takes place by opening of ring. So first SN2 attack will give you inversion of configuration, and after second SN2 attack again there is inversion of configuration. So inversion, finally you will get retention of configuration. In case of toxicity of mustard gas, it is because of neighboring group participation by sulfur, which accelerates the alkylation of reaction. So in this lecture, we discuss about NGP by unshared pair of electrons, as oxygen as a neighboring group and sulfur as a neighboring group. In next lecture, we will discuss remaining point, that is halogen as a neighboring groups and nitrogen as a neighboring group. Thank you.